Dear scientific community, first of all, I would like to sincerely thank the organizers of the conference for the opportunity, honor and pleasure to participate in such an important scientific forum. I am sending my congratulations to the participants of the ICon-MaSTEd conference. I sincerely wish you life in peace, future mathematical and educational mathematical victories. The present work is the results of our rather long scientific research, both in terms of theory, conceptual approach, and practice, methodological and experimental approach. The content structure of the work presentation is offered to your attention. Our pilot study was aimed at clarification of the state of solving the problem in school education. Questions were prepared for mathematical teachers where they react to answer questions about content, features, components of mathematical abilities, features of the methodology of mathematical abilities development, personal quality of teachers and students that ensure the development of mathematical abilities, the presence of students' mathematical abilities, the role of mathematical abilities and personal qualities of students in teaching mathematics. Its results are present in our work. Here we only note that according to mathematical teachers, there is still a lack of scientifically sound method of developing mathematical abilities of students. According to the results obtained and the competency model of education adopted at the state level, the purpose of the study is to establish the role and place of mathematical abilities in the dual nature of mathematical competence, to make semantic and systematic analysis of the structural components, to highlight the methodology of development of this personal formation, to experimentally test its effectiveness. Therefore, the author's definition of mathematical competence is presented in their paper. The doctrine of the dual nature of mathematical competence has been developed. The conceptual position on the duality of its manifestation was embodied in Cartesian realization. The composition of the external manifestation of such competence on the basis of three dimensions: X, semantic-theoretical, Y, procedural-active, and Z, referential-communicative. The three-dimension structure of internal manifestation is represented by dimensions: X, value motivations, Y, reflexive evaluative, Z, personal psychological. In the present study, mathematical abilities are an immanent characteristic, an essential feature of mathematical competence. The single that most represents its personal and psychological dimension. In this paper, we establish correlation between the structural components of mathematical abilities and the measurements of the external manifestation of mathematical competence. In this regard, the task of the present work include an experimental test of the development of mathematical abilities of first-year students and graduate students of the specialty 0-1 for secondary education, future teachers of mathematics. The following types of tasks have been developed: to develop a structural mathematical model of the content line topics, to build a mathematical model of an applied problem situation, to solve a mathematical problem by one of the known methods, to form a generalized way of action in the process of solving typical problems, to match formulas, equations, and their geometric interpretations, to solve a problem of the Olympic type, formulate heuristic prescription and roll down rule guideline for solving it, to compose new open task. The lambda criterion was tested for homogeneity, and it was found that the empirical distribution of mathematical abilities of freshmen and graduates do not differ. The results of the experimental confirmed the need to develop innovative methods of mathematical education. In the course of its development, 6 theoretical and methodological concepts present in our work were introduced. Innovative method of teaching mathematical implements a fundamentally different didactic model of mathematics education, which emphasizes tasks that enable a situation of success, task problems that activate mental activity, the independent formulas of goals tasks, the collective study of a mathematical problem, establishing the method of solving the problem, the formation of the generalized way of solving typical problems, the formulation of semantic theoretical generalization, definition, theorems, algorithmic and heuristic prescriptions, the performance of the reflection action in the teaching of mathematics. According to this model, a development problem method of teaching mathematics has been developed and present in the work. According to the results of a qualitative analysis of the experimental results, the following conclusions were made. First, science of systematic mathematical knowledge, component of structural mathematics think, and a rival in EG. 2. EG students are better as a method of mathematical modeling. 3. The EG of graduate students better distinguish between typical problem situations, makes a generalized method of action algorithms in the process of solving them. 4. Memory for topical mathematical relations, formulas, general resonance algorithms, content and structure of methods and ways of solving problems are more developed in NG students. 5. The problems of mathematical competitions are better solved by NG students. Based on the results of their solution, heuristic instructions, formulate and guidelines drawn up for using typical problem situations. 6. The most talented students have a specific cognitive style. Their mathematical activity is characterized by semantic generalizations and has a science of heuristics. The lambda criterion was used to statistically test the effectiveness of created methodology of mathematical education. The need for further scientific discourse, the acute social demand for competency-oriented and developmental method of mathematical education determines the prospect of our research. Thank you for your attention.